Hello once again, fellow flight simmers. I'm back once again, trying to see if I can show you guys a little something different this time. As I mentioned in my last video, I had just received some DM13A LED driver chips, but I had not had a chance to play with them yet. So I did now. I wired them up to my little test panel here, and I put up some LED lights, and we're going to play around with some of that today. Hopefully, I can make this clear. That's what I always try to do. As you can see, since the last video, I have added a couple of things to the test panel. I already had the TM1637 display, the 4-digit 7-segment display, but I added this Max 7219 8-digit display. This one is pre-built, so I didn't assemble it myself. And then I've added these lights up here. There's two blue ones there. I'm not sure if you can see them. And then all of these right here. So I'm going to show you guys how I wired the DM13A LED driver chip to the test Arduino here. And then we're going to just play around with making the lights do different things. Alright, so like we talked about last time, there are two ways you can wire LED lights to your setup for annunciators or warning lights. The one way is that you can wire them directly to the Arduino, but you will need to put an resistor at the on the negative side of the of each LED. Otherwise, the voltage or the current will be too high, and you'll damage them or burn them out even. So the other way to do it, the DM13A LED driver, and with this one you can put up to 16 LED lights on each one of these. And I only have one in my setup right now that I'm going to show you guys, but pretty much this is the way you wire them. It's pretty straightforward. You need to supply a separate 5 volts or whatever voltage you want to supply to the LEDs, and that is going to determine the resistor that you need. And there is a lot of calculators online that you can investigate so that you can see what the resistor value should be depending on the voltage that you're going to provide the LED lights. And the negative side of the LED light is going to go to each one of these pins on the LED driver. And then you got one of these pins going to the ground, another one going to the ground with a resistor. This one's going to have the 5 volts that you can get directly from your 5-volt rail that you get off of the Arduino itself. And then here we have another pin going to ground. And then we have the blue one going to the D bus line. The purple one is going to the L bus line. And then the green one is going to go to the control pin either on the Arduino or on an output multiplexer board. Okay, so now we're going to look at how that looks on my setup. Okay, so the DM13A is that chip right there. And you can see all the wires that I have. For example, the white ones are the grounds. And I joined them all together, including the one that has the resistor. And then I just sent that one over to my negative on my little power distribution block over there. And then the positive, I got also directly off of my distribution block right there. The red one that's over here on this side, that's the one that's going to my Arduino. I believe I put that one on pin number 42. And then we got the ones going to the data bus, which is that green one and that yellow one. Those are going to the L line and the D line on my data bus distribution block. So that's how it looks wired up right there. I think it's a lot easier to see it on the diagram than it is here, because once you see it over here, it just looks like a lot of wires and it's probably harder to comprehend it. Now the LEDs themselves, Obviously, you're not going to wire them like this when you're building your setup. This is only because it's a prototyping test panel. This red one over here on the bottom is the one that I'm getting the power from the 5-volt adapter that I hooked up to the Arduino. I am not getting that power from the Arduino itself. Remember, it has to be a separate supply. Okay, so what I did is on the power adapter that I got coming into the Arduino, I tapped off of that one right there, and I just basically soldered a wire, and I put that one, I wired it directly to a second power distribution block, this one right here, that I'm only using for the 5 volts for the LEDs. That is not the same one, and it's not tapping off the same power that this one is, which is getting it directly off the Arduino. So the LEDs themselves, as you can see, I wired up all the positive sides of them, and I just basically joined them all together on both this and this one over here, and then I got the 5 volts directly from this power rail that I sent the 5 volts to. And then the negatives, I put them with these colored wires just like I do everything else, and I send those over to the chip itself. So this is where each one of these come in, and I just wrote these numbers on there just so it can help me see the pins. So starting with a 0 through 7 on this side, and then it's going to be 8 through 15 over on this side. And those are the pin number assignments that you're going to put when you do the configuration. Okay, so originally I had these LED lights that I had got, I think of Fry's Electronics, and it's just a cheap set of, I believe they're Fillmore, and it has 3mm ones and 5mm ones, and the brightness is pretty dim on these, as you'll see on the test panel there. And then I got these other ones from Amazon, which is Daikuno, and these are 5mm. They're all the same size, but these are extremely bright. Actually, they're too bright, so you end up having to use a much higher value resistor in order to dim them down. Right there, you can see the voltage that they require and the brightness. So the MCD is the brightness, and as you can see, the green one could go from 15,000 to 20,000. That is extremely bright. Um, and yeah, there's just a whole bunch of them. I think it's about 100 of them total. And it was like $13 for this. And then also, if you're going to be doing a lot of prototyping, I recommend that you get yourself a little set of resistors. I got these also at Fry's, and it's just a whole bunch of them, a whole bunch of different values. And I actually wrote on each one what the value is. That way, when I'm looking for them, I can easily find whatever value I wanna use. So now we're gonna go look at the configuration file here. I'll load up my configuration file. Okay, as you can see, this one is a lot cleaner than my normal one, which has a lot of things in it. Since this is just the one for my test panel, I only have a couple of items in it. Right here is where I got the LED serial um, driver here. So remember, when you want to assign a driver, a DM13A driver, you need to basically click on an empty pin, and then you're going to basically select LED drivers, and that's going to assign it to there. And then once you assign it, when you start giving it assignments, you're going to basically click on that one and then click on wherever you want to put that assignment. So I'm going to pretend that this new one here that I just put in here is going to be the same one that I have here on number 42. But I'm not going to mess around with this one because I already have them, but I'm just going to show you what I did to put each one of them here. And I'm using the default Cessna 172 for this particular one here, so that's just the functions that I'm going to be using for this one here. Okay, so the first one we're going to assign is the one for the HSI source if the navigation is set up for VORs, then it's going to turn on the light for nav1. And basically what that is this little light right here that's lit up on nav. So when you switch it, it goes to GPS. Okay, so we're going to go look for that one here. So for that one, I went to the data table. I went to navigation instruments. I went to HSI, and then you have to look for the ones that have the L, which is for an LED light or an annunciator. So this is the one that would put that one in there. So you would click on that one, select LED single digit digital output, go to your LED driver and select where you want to put it. And now you see that it's there. Now the second one that we're going to do is the generator 1 off bus light, indicator light of the low voltage light. So for that one we go to electric, and I believe we go to generators, and you can see generator 1 bus off, LED single digital light. Go to your LED serial driver and put it in that spot. So now we have that one at number 1. The next one we're going to do is if the navigation is set for GPS. So we go back to navigation instruments, back to HSI, and now we're going to select that the HSI source is GPS. We're going to select LED digital output, go back to our driver, and we'll put that one in number 2. Okay, the next one we're going to do is going to be the transponder reply and the transponder squawk. So for the transponder reply, we go to COM, audio, and transponder. Oh, you go to transponder here on the top, and then you go to transponder reply. Remember, all of these have an L for LED, so you select that one, LED digital single output. You go to your LED driver and you put it in that spot. And we'll do the same one for the identing indicator. We'll put that one on number 4. So now the last one we're going to do is engine RPM. So we're going to build a bar light indication for that one. So what you need to do for that is you need to go to, for example, engine, and then you're going to want an instrument. So you're going to choose engine RPM, and you're going to select LED bar indicator, which is a series of LEDs. And you can also do this with a stepper motor or a pulse width modulating device or a servo. But right now we're only going to do it with an LED indicator light. So basically we're going to go to where we want to put it, which will be 44. And if you look in my little panel here, that's number 8 is the first one. So it's going to go from 8 to 13, which is 6 of them. So we'll select number 8, and then you get this little window here. In this window, you are going to select the value. So this is the value where you want the lights to be lit up. So let's say on the Cessna 172, I'm going to put about 700 RPMs to 2500 RPM. That's about the maximum. Actually, I'll do it to 2300 RPMs. The blink range, now you can select if you want it to be blinking. I think I haven't got that to work, so I'm not going to mess around with that for now. And we want 6 positions, and you want the continuous bar to be displayed so that they light up as you increase the RPM and they all stay lit up. Because if you don't select that, then it will only be lighting up one at a time as it gets higher and higher. So, and you can also have all LEDs off when the value is minimal, but I'm not going to select that either. So I put done, and now that's assigned starting on number 8 and going all the way down to number 13. Now I wanted to show you guys how the configuration file looks. So we go to the explain resources, plugins, and SimVim folder, and we can open up our data configuration file. Now remember, I haven't saved the last things that I added because that multiplexer or that other LED driver doesn't exist. So I'm only leaving the one that does exist. So this right here is my transponder code 7-segment display, and this one right here is my active frequency max 7219 7-segment display. The rest of them, L420 to L428, those are the ones that I assigned for those lights right here. So the it means that it's an LED driver. The 42 is the pin on the Arduino where I have it plugged into, and the 0, 1, 2, 3, and so on and so forth is the pins on that LED driver where I have those lights plugged in. So it's pretty self-explanatory, but the only ones that you do need to see how it's configured, how it saves it, is the engine RPM one. So basically it's saying that it's 6 positions. Well, I'll start at the beginning. So it's a RPM engine 1. The range is 800 to 2500. I think I had put 2300 on the other one, but this is the one that I actually have saved. And then the blinking, and this one I did have blinking, is between 600 and 800 RPMs, which I don't think is working right now. And then the P is how many positions there is. So it's 6 lights. And F equals 1. I believe that might be for the continuous graph, so that it could all stay lit up and not turn off the previous ones. So now we're going to go back over to the airplane, and we're going to put this panel here, and we're going to see how everything behaves. Alright, so the first thing I want to show you is the navigation. So basically I have this switch here set up to change the navigation source. So right now you can see that it's on nav and my yellow light is lit up right here. If I press the switch, you can see on the airplane that it switched to GPS, and now the green light is lit up over here. I know it doesn't really look green, but it's green. This one is supposed to be yellow, but it looks like orange. But anyways, as you can see, when I switch back and forth between that, they switch exactly like the airplane annunciator does. Okay, the red one here, that's gonna be the generator off or the alternator off. So if I turn off the alternator, you can see the red one turned on, and also inside the airplane, you can see the warning, the volts warning right here. And when I turn on the alternator, it turns off. When I turn off the alternator again, it turns on again. Okay, now we're gonna go over to the blue ones, which are extremely bright. So I'm gonna turn on my transponder, and you can see the blue light flashing there. That's every time the reply comes on, and you can see it here in the transponder. Every time this little thing, the R, blinks, which I think means reply, the blue light is blinking. And if I press the ident light, since it's identing and the reply light stays on, the lights stay on too until the identing is done. Alright, so now that the identing is done, it goes back to just its normal flashing. Alright, so we're gonna do the RPM. As you can see right now, only the red light is lit up right here, but as I increase the RPMs, you see that they start lighting up. So now I'm at maximum RPM, which right now here on the ground is about 2250 RPMs, and all of them are lit up. So basically whatever values you put into those fields, that's going to determine how many and when they light up. And you can do like right there, I'm going to leave it like in the middle. So we got 4 of them lit up. I'll go down even a little more, about 1100. So you got only two. And when I go back to idle, only one will be lit up. And you can do different things with these, but you have to be aware of how you're going to wire them. For example, if I wanted to use this for a fuel gauge, I can put that when the fuel is full, basically you're going to have all of them lit up to the green. And then as the fuel goes lower and lower, you could have them start turning off little by little until you get to the bottom, which is going to be the red. And then that's where it would come in handy to be able to make them blink, so that you get that basically, not only will you get the fuel warning in the cockpit, but you'll see your gauge blinking when you're already pretty low on fuel. So, alright, so I'm going to try to do that right now. I'm going to try to make it into a fuel gauge instead of what I have it set up as right now. So what we're going to do is we're going to delete that engine RPM out of here, and we're gonna look for the fuel gauge. So we go to the fuel, we go to indicators, and we can do fuel quantity tank 1. We'll use a LED indicator, and we'll put that on that number 8 right there. Now this right here, you're gonna have to figure out again what your fuel value is in order for you to be able to get the right indications. So once again, you're gonna have to open up the data ref tool, and I guess we can look for fuel. So let's say that we're gonna load it up all the way, and now it's 79. Oh, I guess it's pounds, it's not gallons. So 79 pounds is the maximum. So we're gonna do 80. Let's put 12 as the minimum and 80 as the maximum, because I believe there's about 2 gallons of unusable fuel. And the blink range, let's see if we can make this work. We're gonna make the blink range be from 12 to 20. There's gonna be 6 positions, and we want a continuous graph to be displayed. So we're gonna save it. We'll overwrite our configuration file. Go back to the simulator, reload the configuration. So now, as you can see, all the LEDs are lit up because we have fuel tanks of gas. So they're all green, they're all lit up right now. If we go back into the configuration, let's say we put that much gas. So now we have about 3/4, and you can see one of them turned off. And we can keep on reducing the amount just to see what effect that has. So this is 194 pounds on both of them. Now we're about half, and now we only have 4 of them lit up. And now we have about a third, and we have only 3 of them lit up. Alright, now we have only 2 of them lit up, and that's about a little bit under 10 gallons on each tank. Alright, now we only have 1 lit up. We have about 5 gallons in each tank. So that's 6, that's about 30 pounds. Let me see if we can get it to that critical level where it starts flashing. So let's do 14 pounds. Well, I couldn't get it to flash. I put 12 point something in each tank, and it's still only one of them is lit up. So I'm not sure exactly how that works. I thought I had got it to work once, but I guess I didn't. But anyways, that's kind of what you can do. As you can see now, I made it have the opposite effect. So instead of rising when the RPM is rising, now it's dropping when the fuel level is dropping. Okay, well, I think that's pretty much it for this video. I hope I managed to clear up another area of this amazing software project that SimVim Cockpit is. I have another couple of videos that I want to do. I want to do one still on the little keyboard that I bought. Um, Actually, with SimVim, you can actually create a matrix so that you can put like a bunch of keys, like for example for the FMC, and you don't need to have that many inputs being used up. But I am not that far yet. So I'm gonna just play around with that little keyboard and see what it does, see what I can use it for. I was thinking maybe for the SIVA INS navigation thing for the Boeing 727, but I haven't decided what I'm gonna do yet. For now, I just want to play around with it. But anyways, well, I guess I'll leave you guys with this one, and hopefully you guys get something out of it. All right, until next time.